Hey there, algebra fans. It's Mrs. Lindsay here to talk about graphing systems of inequalities in the real world. In other words, word problems. Here's a typical word problem or a typical real world problem we might encounter. The high school drama club is selling tickets to their charity talent show. The auditorium can hold at most 300 people, and they are hoping to raise at least 2,000 people by selling $5 student tickets and $20 adult tickets. Now, you can tell these are going to be inequalities by the at most and at least. That tells you that we don't have equations, we have inequalities. So, first thing, let's see what are we looking for. In this case, towards the end of the word problem, it's talking about student tickets. Let's let that be X. The number of student tickets. Notice they already tell us how much each student ticket is, $5. So it's not the cost, it's the number of student tickets. We're also looking for adult tickets. Adult tickets cost $20. We already know that, but we're looking for the number of adult tickets. Let's let Y equal the number of adult tickets. Now, I'm going to label the X and Y axis on my piece of graph paper. I still haven't scaled it, and I really have no idea what kind of numbers I'm going to write on this. I may or may not want to count by ones, but I need to find some inequalities and figure out where these 2 points or where these 2 lines are going to intersect and where the shading is going to happen. So first I need to write my inequalities. First inequality we're going to write has to do with money. Let's look at what has to do with money. They are hoping to raise at least $2,000. Well, let's see. What does at least mean? At least means I can earn greater than $2,000, or I can raise equal to $2,000. I just can't add less or raise less than $2,000 by selling all these tickets. So I want to raise greater than or equal to $2,000. And how am I going to do that? Well, I'm going to sell student tickets for $5. Well, let's see. What did we say student tickets were? X. I'm going to write an X here. So 5X and $20 for adult tickets. Let's see. What did I say the adult tickets were? Y. So that would be 20Y. So here we are. 5X plus 20Y is greater than or equal to 2,000. Now let's look at the second inequality, the number of tickets. Remember, this has nothing to do with money. So we're not going to multiply by $5 or $20, and it's not going to add up to at least $2,000. We're talking right now about the amount of people, the 300 people, and it says at most 300 people. So what does at most mean? At most means I can have less than 300 people in this auditorium. That would be okay. I could have equal to 300 people in this auditorium. That would be okay. I just can't have more than 300 people. So I can have less than or equal to 300 people. So let's see. All my students, X, plus all my adults, Y, is less than or equal to 300. So here's my inequality, X plus Y less than or equal to 300. Now it's time to graph these inequalities. We'll start by graphing the line, the boundary line, 5X plus 20Y equals 2,000. I could solve this for Y. I could use my calculator, or I could use the slope and y-intercept, or I could use the x and y intercepts. And I think I might do that. So if I cover up the y, I get 5x is equal to 2,000. When I divide by 5, I'll get my x-intercept. 2,000 divided by 5 is 400. My x-intercept is 400, 0. To get my y-intercept, I want to cover up the x. 20y equals 2,000. If I divide by 20, I'll get my y-intercept. That would be 100. So y-intercept is 0, 100. So here's my inequality for 5x plus 20y is greater than or equal to 2,000. This is the x-intercept of the boundary line, and this is the y-intercept of the boundary line. And we'll graph that. In order to get the x and y-intercept of x plus y is less than or equal to 300, I'll look at the boundary line, x plus y equals 300. If I cover up the y, I'll get my x-intercept. Well, clearly that's x equals 300. And the same is true for my y-intercept. Cover up the x, y is equal to 300. My x and y-intercepts, 300, 0, and for the y-intercept, 0, 300. So now it's time to put some numbers on this graph. And I know I have to get to the x-intercept of 400, 0. So I need to count along the x-axis and get to 400. Well, I only have 10 squares here, so counting by ones is not going to do it. I could count by 40 and get to just barely to 400, or what I did was I counted by 50s. I didn't write each number, all right? I skipped and went to 100. Notice how I skipped first, then went to 100, then skipped 200, skipped 300, skipped 400, and I got up to 500. Why did I get all the way to 500? Because I'd like a little bit of extra room here. Same with the y-intercept, all right? I know I need to get to at least 300, so I just labeled it the same way. I went by 50s. So I got all the way to 500 if I wanted to write that far. Now it's time to graph, and it's pretty easy if you know the x and y intercepts. So to graph the money inequality, the 5x plus 20y is greater than or equal to 2,000, I graph the x-intercept, 400, 0, which is right here, and I graph the y-intercept, 0, 100, which is right here. Now, I know it's a solid line, because of the greater than or equal to. So it's inclusive. So when I connect these 2 points, the x and y intercept, I'm going to connect them with a solid line. And now it's time to shade. Since it's greater than or equal to, I'm going to shade above the line. So notice how I make, as neatly as possible, nice, straight as possible lines. Whoops, that one wasn't as straight as the other ones were. I don't scribble, and I don't color it in, because we're going to be looking for a waffle pattern when I graph my other inequality. Okay, next thing, I do want to label that. So I label my inequality someplace a little bit out of the way. 5x plus 20y is greater than or equal to 2,000, just to show where it is. Now, the next inequality, x plus y is less than or equal to 300, I know my x-intercept, 300, 0, right here, and my y-intercept, 0, 300, right here. Again, I graph with a solid line because it's inclusive. There it is. And then, of course, I'm going to need to shade that because it's less than or equal to. I'm going to shade below the inequality, the boundary line. And there it is. I, of course, want to label this. So again, someplace that's not in the way, I label x plus y is less than or equal to 300. Now, where's my solution set? Well, my solution set is right here in the waffle. It's between these 2 boundary lines. So to label that, I make a big, thick S. And the next thing I'd like to do is pick a point within the solution set to make sure that this is the correct solution set. If this is the correct solution set, then this point, 100, comma, 150, seems to be well within the solution set. So if 100 students bought tickets and 150 adults bought tickets, it would satisfy both constraints. You would make $2,000 at least, and the auditorium would not hold more than 300 people. If I have 100 student tickets and 150 adult tickets, there's my point, right in the solution set. And that should satisfy both inequalities. Now, you could graph these, and what I did was I graphed them on this Desmos website. And again, you would have to know how to scale because Desmos gives you a default scaling of -10 to 10 for the X and Y axis. So you would have to kind of know what you're looking for. But here's your solution set right here if you graph this on the Desmos website. So you can see here, here's your solution set. Here's your two inequalities. This one shows you the constraint of money. You're going to make at least $2,000. And this one here shows you that you're going to have less than or equal to 300 people in that auditorium. So there's a little bit about real-world inequalities and systems of inequalities when you have two constraints or two inequalities on one graph. Hope you learned a little bit, and we'll see you tomorrow.